Good afternoon, Vishnu Priya, Vishnu, Surya. Can you hear me?
Yes, ma'am.
Yes, okay. Okay. Yes, children. Okay, you can start. Okay, today we are going to start with the new chapter, probability. Okay, we are going to discuss about probability. Okay. So what is meant by probability? Probability of an event means? What is meant by probability of an event? Probability means, yes, it is possibility, isn't it? Okay, we use this word every day, isn't it? Almost every day we use. There is a chance. Is that no? We used to say there is a chance that this one will happen. Or there is a chance this team will win. Like that, we use the word chance or possibility. Okay, so now consider the situation when you are tossing a coin. When you toss a coin, what are the possible outcomes? When you toss a coin, what are the possible outcomes? When you toss one coin.
Head or tail.
Okay, tossing coin.
1 by 2.
Okay, when you toss a coin, what are the possible outcomes? Children, write down all these things. Okay, what are the possible outcomes when we toss one coin? Okay, suppose we toss one coin. The possible outcomes are head and tail. We have two outcomes, head and tail. When we toss one coin, two outcomes are there. Okay, so what about the total number here? What is the total number of outcomes here? When we toss one coin, the total outcome is 2 raised to 1, which is 2. When we toss one coin, total outcome is 2 raised to 1, which is equal to 2. When you toss two coins, when we toss two coins, what are the outcomes? What are the possible outcomes? When you toss two coins, what are the possible outcomes?
Head and tail.
Head to tail, then
Tail head.
tail head,
Head head.
tail tail, okay, head head. So how many outcomes are there? What is the total number of outcomes?
4.
4. Okay, so total outcomes are 2 square, which is equivalent to 4. When we toss one coin, we have one outcome. When we toss one coin, 2 raised to 1. Okay, note down here, one coin if we toss, 2 raised to 1. 2 raised to 1 is 2. When we toss two coins, total outcomes will be 2 square, which is equivalent to 4.
Why we take this 2 square like that?
Okay, that is we want to generalize it. Okay. Now we have discussed about one coin, we have two coin. Okay, from there we are going to generalize and we are write the one formula. So now can you guess what will be the outcome when we toss 3 coins? Up to this you completed? You copied up to this?
No, ma'am.
No. Okay. Copy it. Okay. Now write the next one. 3 coins. When you toss 3 coins, what are the possible outcomes? So before writing this, can you guess how many outcomes will be there? How many outcomes will be there? If 1 coin, if we toss, 2 raised to 1.
8.
Yes, very good, Aditya. Okay, so look at here. If we toss 1 coin, 2 raised to 1. If we toss 2 coin, 2 square. So if we toss 3 coins, the outcome will be
2 raised to 3.
this 2 raised to 3, 8 outcomes. 8 outcomes. So what are the possible outcomes? When we toss 3 coins, the possible outcomes are what are the possible outcomes? Yes. You start with 1 head. Suppose 1 head is there, means H, T, T. Is it correct? 1 head and 2 tails. Total 3 outcomes. Then we can write the H in the middle. H, T, H, T. Then T, T, H. 1 head. Next is 2 heads. 2 heads means it may be HHT, HTH, THH, then 3 heads. 3 heads means HHH, and no head. No head means all are tail. So we have 8 outcomes altogether. When we toss 3 coins, we will get 2 cube, which is equal to 8 outcomes. 2 cube, which is equivalent to 8 outcomes. Is it okay? Is it clear, children? The outcomes, is it clear? Lolita? Rajot? Okay? Outcomes? Now, consider the next case. Okay. Now we can do problems based on this coins. Okay, we are going to solve questions based on this. So before that, we have to learn the formula. Okay, so before we learn formula, listen children, what is the formula we have learned for probability? We know that probability means it is possibility. Okay, we know that probability means possibility. What is the formula we have learned for finding probability?
Number of possible outcomes by total number of outcomes.
Number of possible outcomes by total number of outcomes. Okay, actually probability, we are going to classify it into two types. We can classify the probability into two types. We are going to classify this into two types: experimental probability or empirical probability. Okay, listen children, this may be asked for 1 mark question. Experimental probability or empirical probability. In that word itself, it is there. Experimental. What is meant by experimental probability? We can find the probability by doing the experiment. Okay, suppose for example, if you toss a coin 50 times, we can do it and we can find out the probability. Okay, some experiments we can do it again and again. Okay, we can do some experiments again and again and we can write the probability. But there are some experiments we can't do. Okay, for example, what is the probability of success in launching a rocket? Okay, so that and all, is it possible to launch and study? Not possible, isn't it? It is because it is very costly. Then what happens? How the probability? Okay, last year, this is the probability of success. Last year, when we did the experiments, this is the probability of success. So this year, what is the probability? So how they will assess it? Based on the previous experiments, they will go through it. Okay, so some experiments will not be able to do it again and again. In that case and all, what we do? We use the previous data. And based on the data, we calculate the probability. Some experiments, if you're tossing of coin and all, we can do it again and again without loss of money and all. Okay, so probability, we can classify it into two types: theoretical probability or experimental probability. Experimental probability means we can do the experiment. We try the experiment and then find out the probability. Theoretical probability means we take the data which is already existing. From that one, if you find the probability, we call it as theoretical probability. Experimental probability is otherwise called empirical probability. You should know the difference. Okay, 1 mark question and all, this part will be asked. Experimental probability is otherwise called empirical probability. Theoretical probability is otherwise called classical probability. Theory, previous studies and all, if we calculate the probability, we call it as theoretical probability. Theoretical probability, or it is otherwise called classical probability. Theoretical probability or classical probability. So experimental probability means we do the experiments and we find out. So in theoretical probability, based on the previous studies, we take some assumptions, and based on these assumptions, we calculate the probability. Okay, so in experimental probability, listen children, the formula is like this. Probability of an event is equal to number of trials the event happened. Number of trials in which the event happened. Number of trials in which the event happened. Number of trials in which the event happened by total number of trials. by total number of trials. Number of trials in which the event happened by total number of trials. This is what we learned last year. 9th standard, we learned experimental probability or empirical probability. Experimental probability or empirical probability. Here, we do the experiment and we write. So that is why we use the word called trials. How many trials we do? Number of trials in which the event happened by total number of trials. In theoretical probability, the probability of an event is given by number of outcomes favorable to E. Number of outcomes favorable to E by number of all possible outcomes. By number of all possible outcomes. By number of all possible outcomes. So in theoretical probability, probability of an event is given by number of outcomes favorable to E by number of all possible outcomes. Okay, is the difference okay? Is the difference clear? Okay, clear? Rifa? Adidev? Rose?
Yes, ma'am.
Meghna? Okay. Okay. Once again, I'll repeat it. Probability, we are classifying it into two, experimental and theoretical. In experimental probability, we do that experiment again and again. We do it 10 times or 20 times and we write the probability. But in theoretical probability, based on the assumptions, previous trials and all, based on the previous studies, we calculate the probability. Is it okay, Hadi Amin?
Yes, ma'am.
Can you show the board on?
Once you finish this, please tell me. Okay.
Number of outcomes favorable to
Events, E. Okay, that event, we denote it as capital E by number of all possible outcomes. Finished? Is it over? Now, let's write the question. Let us solve few questions based on these coins. Okay. Write the question. Find the probability. Find the probability of getting ahead. Find the probability of getting ahead when a coin is tossed. When a coin is tossed, find the probability of getting ahead find the probability of getting ahead when a coin is tossed.
Head or head?
Yes,
It's in one word or a head.
a head,
Two
separate. It is not ahead. Okay, it is ahead. A head. Find the probability of getting ahead when a coin is tossed once. What is the answer? What will be the answer? When you toss a coin, what is the probability of getting ahead?
1/2.
1/2. Total, there are two outcomes, isn't it? Total, there are two outcomes, and which head we will get only once. So probability of getting ahead is 1/2. Write the next question. Second one. Harpreet tosses two coins. Harpreet tosses two coins simultaneously. Harpreet tosses two coins simultaneously. Find the probability of getting at least one head. Find the probability of getting at least one head. Find the probability of getting at least one head. Harpreet tosses two coins simultaneously. Find the probability of getting at least one head. What is the answer? What is the meaning of at least one head? So before we do this, first you write the outcomes. What are the possible outcomes? When a coin is tossed two times or two coins are tossed once, in both the cases, you can write the total outcomes. What are the possible outcomes? HH, TT, TH, HT, isn't it? These are the four outcomes. When two coins are tossed simultaneously, the possible outcomes are HH, TT, TH, HT. What is the probability of getting at least one head? What is the meaning of at least? At least one head means? What is the meaning? We can
More
one.
than one is also fine.
Yes, yes, very good. More than one is also allowed. One or more. Okay, one and more is allowed. So one head is allowed, two head is also allowed. So which are the possibilities? HH is possible, TH is possible, HT is possible. So what will be the answer?
3/4.
3/4. It will be 3/4. It is 3/4. Okay. Here we are going to learn few terms. Okay. Is it over? Savio? Savio is present?
Yes,
Hmm.
ma'am.
Is it okay? Huh? This one you copied?
Yes, ma'am.
Yes. Okay. Others? Meghna? Nirupama? Is it okay? Shall we move on to the next type? Anjita? Okay, Anjita. Now, for the next one, before we move on to the next one, we have to learn few more terms. First one we are going to learn is a fair game. Okay. Fair game. What is meant by a fair game? Fair game means which is not biased. Okay, that means we can't predict the outcome earlier. Okay, if we can't predict the outcome in advance, okay, either this may happen or that may happen. That means all the chances are given equally. Importance means we call that game as a fair game. Okay, if you toss a coin, we may get a head or we may get a tail. Okay, suppose a two-headed coin we toss. Imagine we have a two-headed coin, and if we toss it, will it be a fair game? I'm having a two. No. Why? Why? Why we say it is not fair one? Will not be getting tail at all. It is a two-headed coin. So all the time we will get head, isn't it? So that means we are favoring for one event. We favor for one event and we are biased. In that case, we say it is an unfair game. Fair game means all the outcomes are to be equally likely. Okay. So such questions will be asked. Some situations will be given and you'll be asked, is it a fair game? Okay, a game is said to be fair if all the outcomes can happen equally. Okay, otherwise we can say that we'll use one more term called equally likely. We call that as equally likely. If all the outcomes are equally likely. If all the outcomes are equally likely, then we can say it is a fair game. So for example, imagine you have 3 blue balls and 5 red balls. Okay, imagine 3 blue balls and 5 red balls. What is the probability of selecting a blue ball? Afsana? Afsana, 3 blue balls and 5 red balls are there. What is the probability of selecting a blue ball? Afsana. Yes, Surya, tell me, Surya, what is the probability of selecting a blue ball? Surya, what is the probability of getting a blue ball? We have 3 blue and 5 red. What is the probability of getting a blue ball? Yes, Hadidi, give the answer, Hadidi. What is the probability of getting a blue ball? Hadidi?
Ma'am, 3/8.
Yes, correct. It is 3/8. What is the probability of selecting a red ball? Probability of selecting a red ball, Johan? Johan, what is the probability of selecting a red ball? Probability of selecting a red ball is 5/8. Okay. Now, in first case, the probability of selecting a blue ball is 3/8. The probability of selecting a red ball is 5/8. Are they equally likely? Are they equally likely? Is it equally likely? What is meant by equally likely? All the outcomes should get equal importance. Now look at here, whether the game is equally likely here. It is not equally likely. Why? Why it is not equally likely? Here, when we take red, the probability is 5/8, which is more, which is greater. So the probability of selecting a red ball is more than the probability of selecting a blue ball. So it is not equally likely. It is not equally likely. This event is not equally likely because the probability of getting red is not same as, it is not equal to probability of taking blue. So imagine another activity. Suppose you have 3 red, 3 blue, and 3 yellow balls. What is the probability of selecting a red ball? Here it will be 3/9, which is 1/3. What is the probability of selecting a blue ball? That is also 3/9, 1/3. What is the probability of getting an yellow ball? That is also 3/9. So it is 1/3. So here the probabilities are same. All the outcomes are given equal importance. So therefore, this is an equally likely. This act is equally likely. This experiment is an example for equally likely. Okay. So some situations will be given and you will be asked to check whether it is equally likely or not. Okay. So look at one such experiment given here. A basketball player attempts to shoot a basketball. A basketball player attempts to shoot a basketball. Is it an equally likely game or not? A basketball player attempts to shoot a basketball. Is it an equally likely one or not? What will be your answer? Yes, Bhadra, Haya. Yes, children, what is that? Yes, Vishnupriya. Yes, this?
Equally likely.
It's not clear. Vishnu, repeat
It
it.
is equally likely.
It is equally likely. He is a basketball player, isn't it? So what happens? Basketball player means he is almost trained in that part, isn't it? Is it clear? So will it be equally likely? No. Okay, he's trained. He's a basketball player. So more chances are there for winning. Less chances for losing. Is or no? If it is if a person like this untrained person, if he throws, there is a 50-50 chance. Sometimes it may fall or sometimes it may not. But he is being a player, if he shoots, there is a more chance for shooting that ball. Okay. So likewise, another question is asked like this. A driver attempts to start a car. The car starts or does not start. Is it likely or equally likely? A driver attempts to start a car. Will it start?
Yes.
Yes, 90% it will start. If there is any problem with the engine or something, means it will not start. Otherwise, driver means he is a skilled person. If he starts the car, surely it will start. Isn't it? So it is not an equally likely game. Next one. A trial is made in a true or false question. A trial is made in a true or false question. Is it equally likely? A trial is made in a true or false question. Is it equally likely?
Yes, ma'am.
Yes, by answer is correct. Why?
Because it can be true or false.
Yes, it is a trial. Okay, trial means what? We don't know. Sometimes it will be correct or it will be false. Okay, so a trial is made to answer a true or false question means it is equally likely. Okay, suppose we know the answer and we attempt a true or false question means we know the answer and we attempt the question. Then will it be equally likely? No, isn't it? In that case, we know the answer. So surely we will be marking the correct answer. In that case, it is not equally likely. Okay, so some situations will be given and you'll be asked to check whether it is equally likely or not. Okay. Similarly, when you toss a coin, if it is a fair coin, and if you toss a coin, the outcomes are equally likely. You may get a head or you may get a tail. We can't predict the outcome. We can say head will occur or tail will occur, but we can't say surely this one will happen or 90% this one will happen. Okay, we can't say like that. So that is why tossing of coin is considered for the games to select. Okay, okay, in cricket and all you might have seen. Okay, tossing of coin. Okay, based on the toss only, we select whether it is batting or bowling. Okay, so the question will be asked like this: why tossing of a coin is considered? Because the outcomes are equally likely. 1 by 2, 1 by 2. Getting a head is 1 by 2, getting a tail is also 1 by 2. So it is equally likely. Now, well, okay, before that, what else we have learned about probability? What else we have learned about probability? Few properties we have learned. What are the properties you have learned? Yes. Can you tell me what are the things you have learned
Yes,
about?
ma'am.
Yes, probability of an event always lies between 0 and 1. Okay, probability of an event lies between, write down this children, write down this as note. Probability of an event lies between 0 and 1. Probability of an event lies between 0 and 1. Second one, probability of a sure event. Okay, probability of a sure event is 1. Probability of a sure event is 1. We know that it will happen surely. In that case, probability of a sure event, sometimes we call this as certain. Okay, probability of a sure event or certain event is 1. Third one, probability of impossible events. Probability of impossible event is, it will not happen at all. So in that case, probability of impossible event is 0. Probability of impossible event is 0. Probability of an event always lies between 1. Next one, sum of all probabilities. When you add all the probabilities, sum of all probabilities. Sum of all probabilities of all elementary events. All elementary events, that means all possible events, when you add up, sum of all probabilities will be 1. Is 1. Sum of all probabilities of all elementary events is 1. Okay, probability of an event always lies between 0 and 1. Probability of a sure event is 1. Probability of an impossible event is 0. Sum of all probabilities of an elementary event is 1. Okay. Is it okay, children? So tomorrow we'll be doing more questions from dice. Okay, problems based on dice and all we'll be discussing tomorrow. Now answer or attendance. Adil Muhammad. Adil Muhammad. Aditya S. Krishna. Aditya S. Krishna. Answer or attendance.
Yes, ma'am.
Aditya M. Aditya M. Amina Shakir. Sorry, Aman Shakir. Aman.
Present, ma'am.
Amina. Amina Naurin. Anne Mary. Anjita.
Present, ma'am.
Anjita.
Present.
Arjun. Ashik. Badra.
Present, ma'am.
Emil. Emil. Fia.
Present, ma'am.
Adidi.
Present, ma'am.
Hadi Amin.
Present, ma'am.
Haya.
Present, ma'am.
Hein Steve. Hein Steve. Johan.
Present, ma'am.
John. John. Rizwan. Lolita.
Present, ma'am.
Meghna.
Present, ma'am.
Melvin. Melvin. Muhammad Aman. Nas Parvin. Nas Parvin. Nirupama.
Present, ma'am.
Surya. Adidev. Prajod.
Present, ma'am.
Pratyush. Rifa. Rifa.
Yes, ma'am.
Rosebi.
Present, ma'am.
Sainaba. Sainaba. Savio.
Present, ma'am.
Vishnu.
Present, ma'am.
Vishnu Priya. Okay, children. So with this, end this today's session now. Okay. Learn this, what formulas, what you have learned, learn the properties and come. Okay. Thank you. Thank you, children.